Hello, in this lecture we'll find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of this square ABCD is equal to 12 units. Therefore AB equals to BC equals to CD equals to DA equals to 12 units. Inside this square we have a circle and a semicircle. This circle is tangent to the square at 2 points, 1, 2, and this circle is also tangent to diagonal AC at this point. And we have also a semicircle. The semicircle is tangent to diagonal AC at this point, and the semicircle is also tangent to this square at point D, and it also touches DC at this point. The center of the semicircle is at point N. The center of this circle is at point M, and we want to find out the distance between the two centers, that is to say the length of MN. Okay, so first of all we will define the point of tendency of tangent AB with this circle as point P. We'll define the second point of tendency of tangent BC with this circle as point Q. We will define the point of tendency of this circle with diagonal AC as point R. We will define the point of tendency of diagonal AC with this semicircle as point S, and we will define the touching point of the semicircle and side DC is point T. And we also will define line segment PB as A. That is to say, line segment PB equals to A units according to our definition. So if PB equals to A units, then, and we know that AB equals to 12 units, then AP will be equal to AB minus PB, that is to say, it will be equal to 12 minus A units. In the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius. Actually, rule number 1, this is rule number 2. Rule number 1 is a little bit different. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. I'll read rule number one again. According to rule number one, the lengths of two tangents from a common external point to a circle are equal. What is the meaning of rule number one? The meaning of rule number one is that if we have this circle and we also have this point P, this point P is defined as an external point in relation to this circle. Why point P is an external point? Because point P is not located inside this circle, nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point. So if from the external point P we draw two tangents to this circle, so the first tangent will be this tangent, and we'll define the point of tendency of the first tangent with this circle as point A. Point A is the touching point of the point of tendency, and we'll draw also a second tangent from point P to this circle. This is the second tangent to this circle. We define the point of tangency of the touching point of the second tangent with this circle as point B. And according to rule number one, the lengths of two tangents, that is to say, the length of the first tangent is PA, and the length of the second tangent is PB. And according to rule number one, the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from the common external point, point P, to a circle, 2 points A and B, are equal. That is to say, PA is equal to PB. So according to rule number one, whenever you draw two tangents to a circle from a common external point, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay? And we can actually implement rule number one in our drawing, because in our drawing we have the external point B. Point B is the external point in relation to this circle. So point B, from point B we have two tangents to this circle. The first tangent is BP, and the second tangent is BQ. And according to rule number one, the length of those two tangents will be equal to each other. That is to say, BP equals to BQ. Okay? but according to our definition, BP equals to A. So from this equation, A equals to BP equals to BQ, we will conclude that BQ is also equals to A. BQ also equals to A. Here BQ equals to A. And because of the fact that BQ equals to A and BC equals to 12, then QC will be equal to 12 minus A. Very simple. And here we'll focus on point A. From the external point A, we have two tangents to this circle. The first tangent is tangent AP, and the second tangent is tangent AR. And according to rule number 1, the lengths of those two tangents are equal to each other, that is to say AP equals to AR. But we have already found out that AP equals to 12 minus A, so we can write here that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR. We will conclude that AR is also equals to 12 minus A. We can write here that AR equals to 12 minus A. We'll continue to focus on point A. From point A, from the external point A, we have two tangents to the semicircle. The first tangent is tangent AS. Tangent AS is tangent to the semicircle as point S. And the second tangent to the semicircle is AD. AD is tangent to the semicircle at point D. Point D is the point of tangency. And according to rule number 1, AS equals to AD. AS equals to AD according to rule number 1. But we know that AD equals to 12 units because of the fact that all the sides of this square are equal to 12 units. AS equals to 12 units. From this equation, 12 equals to AS equals to AD, we will conclude that AD is also equals to 12 units. Actually, we know that AD is equal to 12 units. It is given us in the question that AD equals to 12 units because it is one side of square ABCD that equals to 12 units. And from this equation, 12 equals to AD equals to AS, we will conclude that AS is also equals to 12 units. AS is also equals to 12 units. So here we can write down that AS is also equals to 12 units. So because of the fact that we know that AS is equal to 12 units, AR equals to 12 minus A. Therefore RS will be equal, the value of RS, it is very easy to see from the drawing, that the value of line segment RS will be equal to AS minus AR. AS minus AR. So RS equals to AS, that is 12 units, minus AR, that is, according to what we have already found out, that AR equals to 12 minus A. Here we will open the brackets, and we will get that RS equals to 12, minus 12 which is 0, plus A. In conclusion, we found out that RS equals to A units. RS equals to A units. Here we can write down that RS equals to A units. In the next step, we focus on point C, the external point C. From the external point C, we have two tangents to this circle. The first tangent is tangent CQ. The second tangent is tangent C. It is tangent CR. And according to rule number 1, those two tangents are equal to each other in their lengths. That is to say, CQ is equal to CR. CQ equals to CR according to rule number 1. But we have already found out that CQ equals to 12 minus A. So we can write here that CQ equals to 12 minus A. And from this equation, 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. Very simple. CR is also equals to 12 minus A. So we write down here that CR is equal to 12 minus A. And actually, what is the length of diagonal AC? AC, you can see it from the drawing that the length of diagonal AC is equal to AR plus RC. AR plus RC. Diagonal AC equals to AR plus RC. But we have already found out that AR equals to 12 minus A. AC equals to AR plus RC. So AC equals to AR, that is 12 minus A. And we also found out that RC is also equal to 12 minus A. So in conclusion, we found out that AC is equal to 12 plus 12 is 24. Minus A plus minus A is minus 2A. So in conclusion, we found out that AC equals to 24 minus 2A. AC equals to 24 minus 2A. the next step, I will present to you a new rule that will be rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle, and we know that the center of this circle is at point O, and we also have tangent AB to this circle, here line segment AB, or the tangent AB is tangent to this circle at this point. We define this point, the touching point, or the point of tendency, as point M. So M is the point of tendency, the point where the tangent touches the circle, point of tendency. We will join points O and M together by a straight line. OM, line segment OM is the radius of this circle because of the fact that line segment OM starts from the center of this circle, that is to say from point O, and ends at point M, that is a point of this circle itself. Therefore, this is the definition of a radius. Therefore, OM is the radius of this circle, so we will define it as R. So here, the radius OM is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius MO. AB perpendicular to MO, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Again, according to rule number 2, a tangent to a circle, that is to say AB, is perpendicular to the radius, that is to say radius OM, drawn to the point of tendency. So The reason that the tangent AB is perpendicular to the radius OM because of the fact that the radius OM is wrong, it is wrong to the point of tendency. That is to say, it is wrong to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so we can implement rule number 2 in our drawing. Here we will join points M and P together by a straight line. MP, line segment MP is the radius of this circle because of the fact that it starts from the center of this circle and ends at point P, that is the point on this circle itself. Therefore, MP is the radius of this circle, and the radius of this circle MP is drawn to the point of tendency, that is to say, it is drawn to point P, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to the radius PM. AB will be perpendicular to PM, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And we also know that all the angles inside the square are right angles, so all the angles inside square ABCD are equal to 90 degrees, and especially angle ABC, it must be equal to 90 degrees, as it is one out of four angles of square ABCD, therefore it must be equal to 90 degrees. And we join points M and Q together by a straight line. Here, line segment MQ. Line segment MQ is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point Q, that is a point on this circle itself. Therefore, MQ is the radius of this circle, and the radius MQ is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. Therefore, according to rule number 1, the tangent BC will be perpendicular to the radius QM. Again, the tangent BC will be perpendicular to the radius QM, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So here, in quadrilateral PBMQ, we have three right angles. The sum of three right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle PMQ. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract from this equation 270 degrees, and we get that angle PMQ is equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle PMQ is a right angle. Okay. Right here, that angle PMQ is equal to 90 degrees. So actually, quadrilateral PBMQ has 4 right angles, and therefore quadrilateral PBMQ is at least a rectangle, if not a square. I'll write it down. Quadrilateral PBMQ that has 4 right angles is at least a rectangle, so we relate it as a rectangle. Quadrilateral PBMQ is a rectangle, or at least a rectangle. And we have rule number 3 that states that the opposite sides of a rectangle are equal to each other. I'll write it down. I'll write rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. Therefore, the opposite sides of rectangle PB and Q are equal to each other. That is to say, PB equals to MQ. PB equals to MQ according to this rule, rule number 3. But according to our definition, PB equals to A. So from this equation, A equals to PB equals to MQ, we will derive that MQ is also equals to A. MQ is also equals to A, so we can write here that MQ equals to A. Likewise, according to rule number 3, we get that in rectangle PBMQ, BQ is equal to PM. But we have already found out that PM equals to A. So from this equation we will conclude that BQ is also equals to A. And that here actually BQ equals to A equals to PM. So from this equation we will conclude that PM is also equals to A. BQ equals to A, according to what we have already found out, that, and therefore from this equation A equals to BQ equals to PM, we will conclude that PM is also equals to A. PM is also equals to A. So we actually found out that quadrilateral PBMQ is not a rectangle but a square. Okay. In the next step, we will focus on the right triangle, triangle ABC, the right big triangle, triangle ABC. In the right big triangle, triangle ABC, according to the Pythagoras theorem, in the right triangle, triangle ABC, by PT is abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC squared. It must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AB squared plus BC squared. repeat again. In the right triangle, triangle ABC, the square of the hypotenuse must be equal to the sum of the squares of the perpendiculars. That is to say, AC square must be equal to AB square plus BC square. We have already found out that AC equals to 24 minus 2A, so we'll substitute AC by 24 minus 2A. AC square is 24 minus 2A square. That equals to AB square. AB is 12, so AB square is 12 square. Plus BC square. BC is also 12, so BC square will be equal to 12 square. So we actually found out that according to equation number 1, 24 minus 2A square equals to 12 square plus 12 square is 2 times 12 square. Here we'll take a root out of this equation, equation number 1, and we'll get that according to equation number 1, 24 minus 2A equals to the square root of 2, and the square root of 12 square is 12. Why? Because the root cancels the square and we're left only with 12. So we found out that according to equation number 1, 24 minus 2A equals to square root of 2 times 12. Here we will add to this equation, equation number 1, 2A, and we will subtract square root of 2 times 12, and we get that according to equation number 1, A equals to 24 minus 12 times square root of 2. Here we will divide the equation number 1 by 2, and we will get that the value of A, that is the radius of the circle, is equal to 24 over 2 is 12. 12 over 2 minus 12 over 2 is minus 6. So in conclusion, we found out that A equals to 12 minus 6 times square root of 2 units. That is actually the radius of the circle. Okay? And here we'll find out the value of SC. What is the value of line segment SC? From the drawing, we can see that SC, the value of line segment SC is equal to RC minus RS. RC minus RS, again, SC equals to RC minus RS. That is to say, SC is equal to RC, that is 12 minus A, minus RS, that is A. So in conclusion, we found out that SC is equal to 12 minus A is 12 minus 2A. SC equals to 12 minus 2A, so we can write here that SC equals to 12 minus 2A. In the next step, we will define the radius of the semicircle as B. dn is the radius of the semicircle because of the fact that it starts from the center of the circle and ends at point D, that is a point on the semicircle itself. Therefore, dn will be equal to b as the radius of the semicircle, and t is also the radius of the semicircle because of the fact that it starts from the center of the semicircle, that is to say from point N, and ends at point T, that is a point on the semicircle itself. Therefore, nt is the radius of this semicircle, that is to say it equals to b units. And what is the value of TC, line segment TC? It is very easy to see from the drawing that TC equals to DC minus DN minus NT. I repeat again, the value of line segment TC is DC minus DN minus NT. So TC equals to DC, that is 12 units, minus DN, that is B, minus NT, that is also B. So in conclusion, we found out that TC equals to 12 minus 2B. TC equals to 12 minus 2B. So we can write here that TC, this line segment, equals to 12 minus 2B. In the next step, we will join points N and S together by a straight line. NS is the radius of the semicircle. Why? Because of the fact that it starts from the center of the semicircle, that is to say from point N, and ends at point S, that is a point on this semicircle itself. Therefore, NS is the radius of this semicircle, that is to say it equals to B units, and the radius NS is drawn to the point of tangency, that is to say it is drawn to point S, that is the point of tangency of tangent AC with this semicircle. And whenever you have a radius that is drawn to the point of tangency, then the tangent AC will be perpendicular to the radius CN. AC perpendicular to CN according to rule number 2, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Okay, so we actually found out that the green triangle NSC is a right triangle because it has one angle NSC that are right angle. So we'll focus on the green right triangle and we will implement the Pythagoras theorem on the green right triangle NSC. According to the Pythagoras theorem on the green right triangle NSC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this right triangle is NC. Therefore, the square of the hypotenuse is NC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to Sn squared plus Sc squared. I repeat again, in the right triangle NSC, by Pythagoras theorem, NSC square must be equal, NC square must be equal to NS square plus SC square. And what is the value of NC, the hypotenuse NC? From the drawing, it is very easy to see that NC is equal to NT plus TC. That is to say, NC equals to NT, that is B, plus TC, that is 12 minus 2B. That is to say, NC equals to 12, B minus 2B is minus B. So in conclusion, we found out that NC equals to 12 minus B. And we can write down that NC is equal to 12 minus B. So, according to equation number 2, NC squared, it is actually 12 minus B squared, equals to NS squared. NS is B, so NS squared is B squared, minus SC squared. SC equals to 12 minus 2A squared. Okay, so we found out that according to equation number 2, 12 minus B squared equals to B squared minus, it is actually plus here, is plus SC squared, plus 12 minus 2A squared. So we find out the value of 12 minus 2A squared. Here, 12 minus 2A will be equal to 12 minus 2 times A, and we have already found out that A equals to 12 minus 6 times square root of 2. So here it is equals to 12 minus 2 times 12 is minus 24, minus and minus is plus, plus 2 times 6 plus 12 times square root of 2. So in conclusion, we found out that 12 times square root of 2 and 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2A is equal actually to 12 times square root of 2 minus 12. That is to say, we can substitute 12 minus 2A in equation number 2 by 12 times square root of 2 minus 12. We will do it now and we will get that according to equation number 2, 12 minus B squared is 12 squared plus B squared minus 2 times 12 times B, and it equals to B squared minus 12 minus 2A, and we have already found out that 12 minus 2A, it is actually equals to 12 times square root of 2 minus 12 squared. We substitute 12 minus 2A by 12 times square root of 2 minus 12, and here we have B squared on both sides of the equation, so B squared will get cancelled. So we got here 12 squared minus 2 times 12 is minus 24, B equals to here we will take 12 is a common factor from this expression. So inside the brackets, what is left from this expression after we took from it 12 is a common factor? What is left? It is actually square root of 2. And what is left from minus 12 after we took from it 12 is a common factor? What is left is actually minus 1, all squared. So we get that according to equation number 2, 12 squared minus 24b equals to 12 squared times square root of 2 minus 1 squared. We have here, according to equation number 2, 12 squared minus 24b, that equals to 12 squared. Here we will calculate the value of square root of 2 minus 1 squared. It will be equal to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2. So we got that according to equation number 2, 12 squared minus 24b equals to, we'll open the bracket here and we'll get that 12 squared times 2 is 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. So here we have 12 squared on both sides of the equation, so 12 squared will get cancelled, and we're left only with, in this side of the equation is minus 24b, that equals to 2 times 12 squared. 12 squared is 144, times 2 is 288. Twelve squared is 144, minus 2 is minus 188, times square root of 2. Here we will divide equation number 2 by 24, and we will get that according to equation number 2, minus 24b over 24 is minus b. Minus b equals to 288 over 24 is 12. Minus 288 over 24 is minus 12. Minus 12 times square root of 2. We will multiply equation number 2 by minus 1, and we will get that according to equation number 2, b equals to 12 times square root of 2 minus 12. We found out the value of b, that is the radius of the semicircle. The radius of the semicircle is equal to 12 times square root of 2 minus 12 units. And we have already found out the value of a, that is the radius of the circle. The radius of the circle A, according to equation number 1, is equal to 12 minus 6 times square root of 2 units. And what is the value of A plus B? You can see here that A plus B will be equal to 12 minus 12 plus 12 is 0. 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. In the next step, we will join points M and R together by a straight line. Line segment MR is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point R, that is the point on this circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A units. So the radius MR is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius Rm. AC perpendicular to Rm. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 2, of course. In the next step, from point M, we will draw perpendicular to Rm. From point M, we will draw perpendicular to Rm. So this angle will be equal to 90 degrees, because we did it like that by our construction. Angle Rm, this angle equals to 90 degrees. In the next step, we will extend the radius B and S. We will extend NS, that is the radius of the semicircle that equals to B. We will extend NS until it intersects with the perpendicular from point M. We will define the touching point or the intersection point of the extended NS and the perpendicular from point M as X. Okay? NS is the radius of the semicircle. NS is a radius, it is absolutely a straight line. NS is a straight line, and when you extend a straight line by a straight line, it still will be a straight line. We extended the straight line NS by a straight line, therefore we got an X that is still must be a straight line. So we can write down that NX, line segment NX, is a straight line. When you extend a straight line by a straight line, it must be still a straight line. So NX is a straight line. We have rule number 4 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. I will repeat again on rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, according to rule number 4, if we focus on the straight line NX on this side at point S, which angles we have here? We have here 90 degrees, and we have also angle RSX. 90 degrees plus the size of angle RSX. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 4, that states that the sum of the angles on this side of the straight line NX at point S must be equal to 180 degrees. That is to say, 90 degrees plus the size of angle RSX must be equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we will get that angle RSX, the angle that we are looking for, equals to 180 degrees minus 90 degrees. It equals to 90 degrees. Angle RSX is a right angle, it equals to 90 degrees, so we can throw here a right angle. Okay, so we found out that in quadrilateral RMSX we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle MXS is equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle MXS, the missing angle, equals to 90 degrees. So actually, we found out that all the angles inside quadrilateral RMSX are right angles. And whenever we have quadrilateral before right angles, it must be at least a rectangle. I'll write it down. Quadrilateral RMSX must be at least a rectangle. Okay, this quadrilateral must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other according to rule number 3. That is to say, Rm equals to Sx. Rm equals to Sx according to rule number 3. I will repeat again. Rm equals to Sx in rectangle RMSX according to rule number 3. But we know that Rm is the radius of this circle, that is to say it equals to A. We know that Rm equals to A, and from this equation A equals to Rm equals to Sx, we will derive that Sx is also equals to A. Sx is also equals to A. Here we can write down that Sx equals to A. Likewise, according to rule number 3, Mx equals to Rs, so Rs equals to Mx. Rs equals to Mx, according to rule number 3, that the opposite sides of a rectangle are equal to each other. But we have already found out that Rs equals to A. Rs equals to A, and from this equation, A equals to Rs equals to Mx, we will derive that Mx is also equals to A. Mx is also equals to A. Mx equals to A. So, triangle MXN, the orange triangle MXN, is a right triangle because of the fact that angle MXN is a right angle. So we will implement the Pythagoras theorem on the right orange triangle MXN. According to the Pythagoras theorem on the right orange triangle MXN, the square of the hypotenuse is mn squared. Mn squared must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to mx squared plus xn squared. So according to question number 3, mx equals to a, therefore mx squared is a squared plus xn squared. Here xn squared is a plus b, so xn squared will be equal to a plus b squared, and it equals to mn squared. So I actually found out that according to equation number 3, a squared plus a plus b squared equals to mn squared. The line segment that we are looking for in this question. We have already found out the values of a, b, and a plus b. So we'll substitute a and a plus b in the values that we have already found out. According to what we have already found out, we'll get that a equals to 12 minus 6 times square root of 2, and a squared is squared, this squared, and we have already found out that a plus b equals to 6 times square root of 2, so a plus b squared will be equal to 6 times square root of 2 squared, and this equals to mn squared. Okay. Here we will open the brackets. We'll calculate the value of 12 minus 6 times square root of 2. It is 12 squared plus 6 times square root of 2 squared is 6 squared is 36. 36 times square root of 2 squared is 2. So 36 times 2 is 72. Minus 2 times 12 times 6 times square root of 2. Plus, we already found out that 6 times square root of 2 squared is 72. And it equals to mn squared. So here we have 72 plus 72 is 144. 12 squared is 144. 144 plus 144 is 244. 144 plus 144 is 2 times 144 minus 2 times 6 is 12. 12 times 12 is 144 times square root of 2. And it equals to mn squared. Here we take 144 as a common factor out of those two expressions, and we will get it 144. What is left from this expression after we took from it 144 as a common factor? What is left? It is actually 2. And what is left from this expression after we took from it 144 as a common factor? What is left? It is actually minus square root of 2. And it equals to mn squared. So here we'll take a root out of this equation, and equation number 3, and we'll get that mn is equals to the square root of 144 is 12 times square of 2 minus square root of 2 units. So in terms of numbers, it equals to 9.18 units. So we found out that the value of line segment mn equals to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay, so in the next step, I will summarize the lecture. Actually, we wanted to find out the value of line segment mn and we know that one side of square ABCD equals to 12 units. Inside this square we have circle and semicircle, and we want the center of this circle is at point M, the center of the semicircle is at point N, and we want to find out the distance between the two centers M and N, or we want to find out the length of line segment MN. So in the first step, we define the point of tendency of tangent AB with this circle as point P. We defined the point of tendency of tangent BC with this circle as point Q. We defined the point of tendency of tangent AC with this circle as point R, and we defined the point of tendency of tangent AC with this semicircle as point S, and we defined the touching point of the semicircle with side DC as point T. Then we defined PB as A. So if PB equals to A, then, and we know also that AB equals to 12 units, Therefore, AP will be equal to 12 minus A. Then I presented to you a new rule that is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. We have this circle, and point B is an external point in relation to this circle. Why? Because point B is not located inside this circle, nor on this circle, but it is located outside of this circle. Therefore, point B is defined as an external point in relation to this circle. So if from the external point B will draw two tangents to this circle, the first tangent is PA, the point of tendency of the first tangent with this circle is at point A, and the second tangent is tangent PB, the point of tendency of the second tangent with this circle is at point B, and the length of the first tangent is PA. The length of the second tangent is PB. According to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. So whenever you draw two tangents to a circle from a common external point, like in this drawing, point P is a common external point. Whenever you do two tangents to a circle from a common external point, then the lengths of those two tangents will be equal to each other. That is to say, PA will be equal to PB. And we actually implemented rule number 1 in our drawing. In our drawing, we have first of all, here point B is a common external point, and from this external point B in relation to the circle, it is common external point. We have two tangents to this circle. The first tangent is tangent BP, the second tangent is tangent BQ, and according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, BP equals to BQ. BP equals to BQ according to rule number 1. But according to our definition, BP equals to A. Here, BP equals to A according to our definition. So from this equation, A equals to BP equals to BQ, we will conclude that BQ is also equals to A. Here, BQ equals also to A. Likewise, we focus on point A. Point A is a common external point. And from point A, we have two tangents to this circle. The first tangent is tangent AP. The second tangent is tangent AQ. The second tangent is tangent AR. And the first tangent is tangent AP. According to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, AP equals to AR. But we have already found out that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR, we will conclude that AR is also equals to 12 minus A. Here we can write down that AR equals to 12 minus A. We will continue to focus on point A. Point A is a common external point in relation to the semicircle. From point A, we have two tangents to this semicircle. The first tangent is tangent AD. The second tangent is tangent AS. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AS equals to AD. But we know that AD equals to 12 units. It is one side of square ABCD. So from this equation, 12 equals to AD equals to AS, we will conclude that AS is also equals to 12 units. So we can write here that AS equals to 12 units. So what is the value of RS? We know that AS equals to 12 units. We know that AR equals to 12 minus A. And RS will be equal to AS minus AR. RS equals to AS minus AR. Very simple. RS equals to AS minus AR. So RS equals to AS, that is 12 units, minus AR, that is 12 minus A. So 12 minus 12 minus R is 12 minus 12 is 0, minus and minus is plus. So we found out that RS equals to A units. Here, line segment RS equals to A units. Then we focus on point C. From point C, the external point C, we have two tangents to this circle. Tangent CQ and tangent CR. And according to rule number 1, CQ must be equal to CR. Because from the common external point, we have two tangents, therefore the length of those two tangents will be equal to each other, that is to say CQ equals to CR. But we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. Here, CR is also equals to 12 minus A. What is the value of diagonal AC? Diagonal AC, it is very easy to see from the drawing that diagonal AC is equal to AR plus RC. AC equals to AR plus RC, but we have already found out that AR equals to 12 minus A, and RC equals to also 12 minus A. So in conclusion, AC will be equal to 12 minus A plus 12 minus A, that is to say, AC equals to 12 plus 12, that is 24, minus A is minus 2A. So in conclusion, we found out that the length of diagonal AC is equal to 24 minus 2A. Okay? Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have here this circle, the center of this circle is at point O. We have tangent AB, that is tangent to this circle is point M. Point M is the point of tendency of tangent AB with this circle. OM is the radius of this circle because of the fact that it starts from the center of this circle, and line segment OM ends at point M, that is the point of this circle itself. Therefore, OM is the radius of this circle. We have the radius OM that is drawn to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, the tangent AB will be perpendicular to the radius OM. AB is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. We will implement rule number 2 in our drawing. We implemented rule number 2 in our drawing. We join points M and P together by a straight line. MP is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point P, that is a point on this circle itself. Therefore, MP is the radius of this circle, and we have the tangent and the radius MP, it is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle, and whenever you have radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, the tangent AB will be perpendicular to the radius PM. AB perpendicular to PM, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we know that all the angles inside the square are right angles, therefore angle ABC equals to 90 degrees. Likewise, we join points M and Q together by a straight line. MQ is the radius of the circle because of the fact that it starts from the center of the circle, that is to say from point M and ends at point Q, that is a point on this circle itself. Therefore, MQ is the radius of this circle, and we have the radius MQ that is drawn to the point of tendency. That is to say, the radius MQ is drawn to point Q, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, the tangent BC will be perpendicular to the radius QM. BC equals BC perpendicular to QM. That is to say, this angle equals to 90 degrees, and this angle also must be equal to 90 degrees. So in quadrilateral PBQM, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of angle PMQ in total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. 270 degrees plus the size of angle PMQ must be equal to 360 degrees. We subtract the 270 degrees from this equation, and we got that angle PMQ equals to 360 degrees minus 270 degrees. It is actually 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees. We actually found out that in quadrilateral PBMQ we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral PBMQ as a rectangle. And we have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle PBMQ are equal to each other. That is to say, PM equals to MQ. According to rule number 3, PM equals to MQ. But PB equals to A according to our definition. So from this equation, A equals to PB equals to MQ, we will conclude that MQ is also equals to A. MQ is also equals to A. So the radius of the semicircle is A. Likewise, we know that BQ is equal to PM according to rule number 3. BQ equals to PM. But we have already found out that BQ equals to A. So from this expression, A equals to BQ equals to PM, we conclude that PM is also equals to A. So we actually found out that quadrilateral PBMQ is not a rectangle but a square, but because of the fact that all of its sides are equal to each other, they are equal to A units. Then we focus on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square must be equal to AB square plus BC square. In the right triangle, triangle ABC, according to the Pythagoras theorem, AC square must be equal to AB square plus BC square. We have already found out that AC equals to 24 minus 2A, so AC square will be equal to 24 minus 2A square, and it must be equal to AB square. AB is 12, so AB square is 12 square, plus BC square. BC is 12, so BC square is 12 square. So here we have 24 minus 2A square equals to 12 square plus 12 square is 2 times 12 square. We took out of this equation, equation number 1, and we found out that 24 minus 2A equals to the square root of 2 times square root of 12 square. The square root of 12 square is 12. Why? Because of the fact that the root cancels the square, and we left only with 12. So we found out that, according to equation number 1, 24 minus 2A equals to square root of 2 times 12. Here we added 2A to this equation, and we subtracted square root of 2 times 12 from equation number 1, and we got that according to equation number 1, 2 times A equals to 24 minus 12 times square root of 2. We divided equation number 1 by 2, and we got that A, the radius of the semicircle, the radius of the circle, equals to 24 over 2 is 12, minus 12 over 2 is minus 6. So the radius of the semicircle, the radius of the circle, A is equal to 12 minus 6 times square root of 2 units. Then we define the center of the semicircle, the radius of the semicircle as B, that is to say here DL, this is the radius of the semicircle equals to B, and that is also the radius of the semicircle equals also to B units. And here, but first of all, we found out the value of line segment SC. The value of line segment SC is equal, SC equals to RC minus RS. SC equals to RC minus RS. We have already found out that RC equals to 12 minus A. RS equals to A, so SC in conclusion equals to 12 minus A minus A. 12 minus A minus A is 12 minus A. So we found out that SC, line segment SC equals to 12 minus 2A. Likewise, we found out the value of line segment TC. The value of line segment TC, it will be equal to DC minus DN minus NT. We'll repeat again. TC equals to DC minus DN minus TN minus NT. So TC equals to DC that is 12, TN that is B, TN NT that is B. So in conclusion, we found out that TC equals to 12 minus B minus B. That is to say, TC equals to 12 minus 2B. Then, actually, we have already found out that B equals to 12 times square root of 2 minus 12, A equals to 12 minus 6 times square root of 2, and A plus B, if you add A to B here, you will get that minus 12 plus 12 is 0, and you have 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2 units. So in conclusion, found out that A plus B equals to 6 times square root of 2 units. And then we here, actually we found out that this equals to 12 minus 2b. Then we added points N and S together by a straight line. NS is the radius of the semicircle, that is to say it equals to B units. And we have the radius NS, it is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this semicircle. Whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius SN. AC perpendicular to SN, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So, therefore, the green triangle NSC is a right triangle. Triangle NSC is a right triangle, so according to the Pythagoras theorem, SC square equals to SN square plus SC square. Here, NC square equals to NS square plus SC square. What is the value of NC? NC equals to NT plus TC. So NC, the hypotenuse, equals to NT, that is B, plus TC, that is 12 minus 2B. NC equals to B plus 12 minus 2B. 12 plus, so B, it is 12, plus B minus 2B is minus B. So in conclusion, found out that NC, the hypotenuse NC equals to 12 minus B. And so according to the Pythagoras theorem, NC square is 12 minus B square equals to NS square, that is B square, plus SC square, that is 12 minus 2A square. So in conclusion, according to equation number 2, 12 minus B square equals to B square plus 12 minus 2A square. So here we have to find out the value of 12 minus 2A in equation number 2. We have already found out the value of A, so what will be the value of 12 minus 2A? 12 minus 2A will be equal to 12 minus 2 times A, and A, we have already found out that A equals to 12 minus 6 times square root of 2 units. So 12 minus 2A is 12 minus 2 times, minus 2 times 12 is minus 24. And minus 2 times minus 6 is plus 12. So it is 12 minus 24, that is minus 12, plus 12 times square root of 2. So in conclusion, we found out that 12 minus 2a equals to 12 minus square root of 2 minus 12. Therefore, we can substitute 12 minus 2a in this equation, equation number 2, by 12 times square root of 2 minus 12. We did it, and we got that here we open the brackets. 12 minus b squared equals to 12 squared plus b squared minus 2 times 12 times b, that equals to b squared. And here we substituted 12 minus 2a squared by 12 times square root of 2 minus 12 squared. And we got that we have b squared on both sides of the equation, so b squared will get cancelled. What is left from equation number 2 after we cancel b squared? What is left? It is actually 12 squared. Minus 2 times 12 is minus 24. So here, in this of the equation, we have 12 squared minus 24 on b. That equals to, here we took 12 as a common factor out of this expression. And what is left from this expression after we took 12 as a common factor? What is left is square root of 2. And what is left from minus 12 after we took from it 12 as a common factor? What is left? It is actually minus 1. So here we have 12 squared minus 24b equals to here 12 square, and here we have square root of 2 minus 1 square. So we got 12 square minus 24b equals to 12 square times square root of 2 minus 1 square. So we have here 12 square minus 24b equals to 12 square. We open the brackets here. Square root of 2 minus 1 square is square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1, that is minus 2 times square root of 2. That is actually minus 2 times square root of 2. And in conclusion, we found out that according to equation number 2, 12 squared minus 24b equals to, we open the brackets here, 2 times square root of 12, plus 1 times square root of 12, minus 2 times square root of 2 times 12 squared. Here we have 12 squared on both sides of the equation, so 12 squared will get cancelled, and we left only with minus 24b, that equals to 12 squared is 144, 144 times 2 is 288, minus, here we have 12 squared, that is 144, minus 2 is minus 288. So in conclusion, according to equation number 2, minus 24b equals to 288 minus 288 times square root of 2. We divided the equation number 2 by 24. Minus 24b over 24 is minus b. 288 over 24 is 12. Minus 288 over 24 is minus 12. So in conclusion, we learned that according to equation number 2, minus b equals to 12 minus square root of 2. We multiplied the equation number 2 by minus 1. And we got that according to equation number 2, according to equation number 2, b equals to 12 times square root of 2 minus 12. We have already found out that a equals to 12 minus square root, a equals to 12 minus 6 times square root of 2. And what is the value of a plus b? Here, a plus b, here we have minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2. Then we have here we join points M and R together by a straight line. MR is the radius of this circle because of the fact that it starts from the center of this circle and ends at point R, that is a point on this circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A. And here we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say the tangent AC will be perpendicular to the radius Rm. AC perpendicular to Rm, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And then from point M we draw perpendicular to Rm, so this angle is equal to 90 degrees. Angle Rmx equals to 90 degrees. And then we extended NS by a straight line until it intersects with the perpendicular from point M. We define the intersection point of the extended NS and the perpendicular from point M as point X. And so here we have quadrilateral RMSX, but before that we know that NS is the radius of the semicircle, and as a radius must be a straight line. NS is a straight line, and when we extended the straight line NS by straight line, we got NX, that it is still a straight line, because when you extend a straight line by straight line, it must be still a straight line. So we got NX, that is still a straight line. NX is a straight line, and we have rule number 4 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus, we know that NX is a straight line, so if we focus on this side of the straight line NX as point S, then the sum of the angles at this point must be equal to 180 degrees. So here we have 90 degrees plus the size of angle RSX. In total they must be equal to 180 degrees. Here 90 degrees plus the size of angle RSX. In total they must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation and we got that angle RSX equals to 180 degrees minus 90 degrees is 90 degrees. So in quadrilateral RMSX we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the size of the fourth angle, that is actually angle MXS. In total they must be equal to 360 degrees. In quadrilateral RSMX, the sum of the angles must be equal to 360 degrees. That is to say the sum of 3 angles, that is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total they must be equal to 360 degrees. We subtracted 270 degrees from this equation and we got that the size of the fourth angle, that is actually angle MXS, equals to 360 degrees minus 270 degrees is 90 degrees. So the size of this angle MXS is equal to 90 degrees. Therefore quadrilateral RMXS has 4 right angles, and any quadrilateral that has 4 right angles, it must be at least a rectangle. So here we can write down that quadrilateral RMSX is at least a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle RMSX, the opposite sides are equal to each other. That is to say, RM equals to SX. RM equals to SX according to rule number 3. But we have already found out that RM equals to A. So from this equation A equals to RM equals to SX, we will derive that SX is also equals to A. Here SX is also equals to A. Likewise, we in rectangle RMXS, MX must be equal to RS. MX must be equal to RS. But we have already found out that RS equals to A. So from this equation A equals to RS equals to MX, we will conclude that MX is also equals to A. Here MX is also equals to A. So actually we found out that quadrilateral RMXS is a square because of the fact that all of its sides are equal to each other. Then we focused, and because of the fact that angle MXN is a right angle, then the orange triangle is a right triangle. Triangle MXN is a right triangle, so we can implement the Pythagoras theorem on the orange right triangle, triangle MXN. According to the Pythagoras theorem, mn squared equals to mx squared plus xn squared. Mn is the hypotenuse, so the square of the hypotenuse is mn squared. It is equals to the sum of the squares of the perpendiculars, that is to say it equals to mx squared plus nx squared. So, what is the value? Mx is a, so mx squared is a squared, and nx is a plus b, so nx squared is a plus b squared. So in conclusion, we found out that mn squared is equal to a squared plus a plus b squared. And we have already found out that a equals to 12 minus 6 times square root of 2, so 12 squared. So a squared will be equal to 12 minus 6 times square root of 2 squared. And we have already found out that a plus b equals to 6 times square root of 2, therefore a plus b squared will be equal to 6 times square root of 2 squared. We open the brackets on this equation number 3, and we got that 12 minus 6 times square root of 2 squared is equal to 12 squared, and 6 times square root of 2 squared is 72, minus 2 times 12 times 6 times square root of 2, plus 6 times square root of 2 squared is 72. So here we have 72 plus 72 is 144. And 12 squared is 144. 144 plus 144 is 2 times 144. Minus 2 times 6 is 12. 12 times 12 is 144. So this expression equals to 144 times square root of 2. So in conclusion, we found out that according to equation number 3, 2 times 144 minus 144 times square root of 2 equals to mn squared. We took 144 as a common factor out of these two expressions, and after we took 144 as a common factor, what is left of this expression? What is left is actually 2. What is left from this expression after we took from it 144 as a common factor? What is left is actually minus square root of 2. So in conclusion, we found out that according to equation number 3, 144 times 2 minus square root of 2 equals to mn squared. We took a root out of this equation number 3, and we found out that mn, the distance between the centers of the semicircle and the circle, is equal to the square root of 144, that is 12, times square of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. I'll repeat again, the distance between the centers of the semicircle and the circle, that is to say the length mn, is equal to either 12 times square of 2 minus square root of 2, or in terms of numbers, it equals to 9.18 units. Okay? Thank you very much.